Okay, back here, we want to fix the bug from the last lecture. So we have a list of two numbers, and we want to get three smallest numbers in this list. And as you remember from the debugging session in the last lecture, this problem happened in this line here. So at some point, the input list that we give to this method becomes empty, and we try to find the minimum number in an empty list. Now, we have two choices to fix this problem. We can put a conditional statement here and make sure the list is not empty. That's one way. The other way is to have a conditional statement in this method here. So we want to make sure the count that we get here is not greater than the number of elements in this list. Now, both these solutions might sound reasonable, but which one do you think is a better solution? I think a better solution at this point is to check if count is not greater than the number of elements in this list. Why? Because we're asking a question in this method, but the question itself has a problem. If the question is meaningless, we cannot get an answer. Let me use a metaphor. Imagine you ask your friend, do you eat with a pen and paper? Doesn't make sense. The question should be, do you eat with a spoon and fork or with chopsticks? So when the question is meaningless, we cannot provide an answer. So in this case, I'm going to attack this problem by making sure this method gets smallest, gets the right arguments as the question. Now, so I'm checking. If count is greater than the number of elements in this list, then we throw an exception. Exception of type argument out of range exception. This is a useful technique in defensive programming. So we check the input first before doing any processing. Now, one more thing I would like to add here. We can add a message here. Count cannot be greater than the number of elements in the list. Let's run the application now. The application crashed again. So have we solved the problem? Yes, we did solve a part of the problem. Now you might ask, Mosh, how is this better than before? Because before we got an exception anyway. Let's see the difference. Read the exception. Argument out of range exception. Count cannot be greater than the number of elements in the list. So this exception is more meaningful. It's telling me why the program crashed. So when it comes to troubleshooting, I would have a better idea of what's happening here. I would know that the client of this method, in this case, this line here, is sending the wrong data. Let me temporarily comment out these two lines here. And run the application again. Read the error now. Index was out of range. Must be non-negative and less than the size of the collection. This error message is too low level and is coming up from a method further down in the list of method calls. So it came from this method here. The important thing to consider here is we should not get here in the first place. The program should stop execution at this point, and that's why we added this if block here. The reason I add this here is not just to display a more meaningful message. It's to prevent your application from going in the wrong state. Now, this is a very simple program, but imagine if this was a big real-world application with a database. If your application goes in the wrong state, there is a chance that sometimes that state gets persisted in the database. And then next time you load a page, you show some data to the user that makes no sense. And in situations like that, you're going to have a hard day finding that bug. You're going to spend a day or two, maybe even a week, to figure out what was happening. Okay, back to the business here. Now we solved this problem with this count being greater than the number of elements in the list. What if count is 0? Do you think it's a valid question? Give me 0 smallest numbers. No, it's a ridiculous question. What if it was -1? It just doesn't make sense. So we need to change this slightly to something like, so if count is greater than the number of elements in the list, or smaller than or equal to 0, that's out of range. Of course, we need to change this message slightly. Count should be between 1 and the number of elements in the list. Let's run the application. Okay, we got this meaningful exception here because we passed -1 to this method. Now, to further expand this topic of defensive programming, what if we send an empty list here? Something like this. You might say, okay, Mosh, we can do another check here to make sure that the list is not empty. We can certainly do that, but in this case, I can show you that the existing logic would work for an empty list. Why? Because first of all, I know we cannot send -1 or 0 here, so we need to send 1. And because 1 is greater than the number of elements in the list, this logic will stop the program execution. So there is no need to write if list.count is 0, throw an exception. It's just redundant. But what if the list was null? What if I send null here? Then I'm going to get another low-level exception further down the track. So let's investigate that. Run the application. The famous null reference exception. Object reference not set to an instance of an object. So this is something that I would like to prevent at the beginning of this method to make sure the question is the right question. So if list is null, we throw an argument null exception. Okay, so in this lecture, we covered some of the edge cases around this algorithm, and we improved the reliability of our code. And that brings us to the end of this lecture. Over the next couple of lectures, I'm going to show you more debugging tools in Visual Studio. I hope you enjoyed this lecture, and thank you for watching.